Test review question number 1, we're going to classify these as continuous, categoric, or numerical. Well, this is country, so it's categoric. And you might also be asked on the test to classify something as discrete or continuous. So this is numerical, and I would classify it as continuous. The scores of team members on a dart competition, well, they can either score a point or not a point, so it is numerical, but in this case it's going to be discrete. Quantitative discrete or a numerical discrete. Question number 2. Okay, given this data, how many small business give data to a survey? So I'm going to add up all the total businesses. So that's adding my frequencies. So there were 49 small businesses in this survey. How many of the businesses have only 1 or 2 full-time employees? So that's 15. What percentage of business have 5 or more employees? Well, adding up the frequencies for the more than 5 or more, divided by the total amount, times by 100, we have a frequency of 26.53%. D, describe the distribution. Remember, I need 3 sentences here. One sentence describing the shape of the distribution. So this distribution, the distribution of the number of full-time employees of a randomly selected sample of small businesses, is positively skewed. And remember, in the measure of center, you can use the mean, median, or mode. I'm going to use the mean in this case. So let's see. The average number of full-time employees at the selected small businesses is approximately 3.51 full-time employees. The third sentence you should write describes the spread of the distribution. So I'll use the range in this case. The number of full-time employees, small businesses in our survey, has a range of 7. Number 3, we're looking at A. What are the variables of investigation? Well, the variable we're looking at is the number of children that are in a household of our 20 students that we're surveying. So there's the number of children. B, is the data discrete or continuous? Why? Well, it'd be discrete, and our reason for that is we cannot have part of a child. Next, we're going to draw a dot plot. So I'm going to draw a number line, and then I'm just going to start plotting the data, and I'm just doing it as the order we're getting. When you're done, it should look like this. D, how would you describe the distribution of the data? So again, we're going to talk about 3 things. First, the shape of the distribution in any unusual features. The second, the measure of center. And third, the spread of the data. So let's first talk about the shape of the distribution. The number of children in a household of 20 students is positively skewed with an outlier at 8. Next, we'll talk about the measure of center. Now, you can do mean, median, or mode. I'll choose median in this case. The median number of children in a household from our sample is 2. How did I come up with the 2? Let's look at this. So I just figured out the number of data I had in my sample, and then I found the dot in the middle, which in this case there's 2 dots in the middle, but they're both 2. 2 plus 2 divided by 2 is 2. Now, last time I talked about my measure of spread as range, but this time let's do the interquartile range. So I'm over here to the side. What I'm doing is I'm figuring out my quartile 1, my quartile 2, my median, and my quartile 3. Because remember, interquartile range is Q1 minus Q3. So quartile 1 is 1.5. Quartile 3 is the middle values are 3 and 3, so quartile 3 is just 3. So my interquartile 1 would be 3 minus 1.5, which is 1.5. So I could say that the middle 50% of my data has a spread of 1.5, or the data has an interquartile range of only 1.5 children. That tells me that my data is very clustered together, especially when I disregard my outlier of 8. Question number 4. This time we're going to construct a stem and leaf plot. First, I'm just going to use the raw data that's out of order and put it straight into my stem and leaf plot. Remembering to make equal spacing and lining up my columns. Finally, I need to make a key so I can read the stem plot. We'll let 2 line 7 represent a mark of 27. I don't know why I put 40 there, 27. And for part B, we're just going to put our numbers in increasing order, making a key for the data. 2 line 1 represents a mark of 21. C, what's the advantage of a stem leaf plot? Well, it lets us see each individual data value. Whereas a frequency table, we just see the values in a range of data. D, what is the highest score? Well, that would be our maximum value, and we can easily see that from our stem plot as at 40. And our minimum, also from our stem plot, is easy to see is 9. A would be a score of 36 or more, so let's look at how many we have of 36 or more. That's 6 of them. We had a total number of 30 data points, times that by 100, and 20% of the students scored an A on this exam. 5. A scores have an average of 6. We're going to let y equals the sum of the 8 scores. So y divided by 8 will equal 6. So that lets us say that y equals 48. So the first 6 scores had a sum of 48. Then we're going to add 2 more scores. So we got plus 15 plus x, and now we're dividing by 10. And we're going to replace the y with 48. Solve this equation for x. And we have that x is equal to 7. 6a, find the minimum weight. Well, that's 32 kilograms. B, maximum weight, 91 kilograms. C, the number of students with a weight greater than 52 kilograms. So let's see how many we have. So we start there and we count all of these individuals. And we get 20 students. D asks us the number of students with a weight at least 70 kilograms. So we count all the students starting at 70, and that gives us 5. And the percentage of students that weight less than 48, so we count all the students less than 48, which is 7 students. Divide by the total number of students in the survey, times by 100, and we get 20%. Here we're going to look at our frequency table. I'm going to explain why mass is a continuous variable. Well, mass is a continuous variable because you don't have to have just one count by gram. You can have part of a gram or a decimal value. Okay, let's construct a histogram of this data. So on our x-axis, we have our mass of x, and on our y-axis, we have frequency. And then we're going to make our bars to the height of each frequency. So the first 2 only have a height of 1. Second one is way up here at 16. Fourth bar is at 4, and the last bar is at a height of 3. What is the modal class? Well, the modal class is the class with the most frequency, so that would be from 50 to less than 51 grams. Describe the distribution of the data. Okay. Starting by the shape. Well, this distribution of the mass of eggs in a carton marked 50 grams is symmetrical, or approximately symmetrical. With a mode of 50.5 grams, because I'm using the middle number of my range in my class interval. And last but not least, we'll talk about our range, or our spread of our data. And so I'll use the range. So the range of the data is only 5 grams. Okay, to help me out with number 8, before I start answering all these questions, I just want to get my numbers in order. You can do this any way you want to. I just think stem plots are really easy ways to arrange the numbers in order. So that's what I'm doing here. I'm just making a rough stem plot. I'm doing it, and since this is not required, I'm just going to do very rough. I'm not going to do a key on it. And now I'm going to put it in order. And this is just my work to help me out to answers A through F. And then this bottom stem plot is what I'm going to use for my answers. Okay, to find our mean, well, we're just going to take all these numbers, we're going to add them together. So you don't have to show all your work, but remember you need to show at least the first two values, and then dot 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 plus the last value, divide by how many total data points you have. In this case we have 21. Punch that into my calculator, and I figure out that the mean is 29.57. B, the mode, well, which one occurs most often? Well, that would be 16 and 28. So we have, this is a bimodal data distribution. C, the median, well, again, this is where the stem plot comes in easy. It's easy for me to find the middle number, so it's going to be 29. The range is going to be max minus min, so it's 45. The upper quartile is a fancy word for quartile 3, and the lower quartile is a fancy word for quartile 1. So I figured out my quartile 1 is 22. Quartile 3 is in between these two numbers, and so I can add those together, and I end up that quartile 3 is 41.5. So quartile 3 is the upper quartile, quartile 1 is lower. Find the interquartile range, well, that's quartile 3 minus quartile 1, so let's subtract these two numbers, and we get 19.5 is our interquartile range. Number 9, this time we're given a graph, so we're given a box plot, and we're asked information about it. So this is just testing to see if you know how to read graphs. Now this can be either the box plot, the stem plot, any other graphs we learned this year. So median score, that's the line in the middle, is 48. Maximum score is the dot at the end. Minimum score is the dot at the beginning. And our upper quartile is our top line at the end of the box. That's 66. And our lower quartile is the bottom of the box, so that's 42. Well, what is the range? Well, the range is our max minus a min. So our range in this case will be 98 minus the 48. Oh, sorry, minus 15, which is 83. And our interquartile range is Q3 minus Q1. So that'd be 66 minus 42, which gives us 24. Is our interquartile range. So 50% of our data is in a range of 24 value points. Construct a 5-number summary. So 5-number summary, remember that's the min, quartile 1, median, quartile 3, and max. This time we're given a stem plot to help us answer the questions. So our minimum is going to be $8.60. Our maximum is going to be $12. Our median is the number in the middle. There's two numbers in the middle, so I need to add them and divide by 2. And that gives me 11. No, that is wrong. That gives me 10 point. That gives me $10.15. Quartile 1 is halfway between, is the middle of my lower half of my data, so that's between the 5 and the 7 there, so that's 9.60. And quartile 3 is halfway between the 3 and the 6, or 11.3 and 11.6, which is 11.45. B, let's draw a box plot. Here you have it. You can check this if you need to check by it. Make sure you label everything. Range of your data, well, that's max minus min. 3.4. Interquartile range, Q3 minus Q1, which is $1.85.